Hello, Mr. Yashar, and maybe also my friends, of course, if you watch. Welcome to my presentation of week 7. We have 9 topics. We will see 9 total. So let's continue with Zoom. Hello again. Welcome my presentation. Our topics are generally science and technology in the 19th century, and we will compare 18th century with 19th century a little bit. So our topics here, and let's start with science becomes professional. What I mean by saying professional, guys, let's think about it. Professional means a job, a work, paid work, right? Yes. 19th century underwent many changes. It's while 18th century scientists were not wealthy and depend on uppers, depend on people that finance them, right? Yes. But in the 19th century, being a scientist became a paid profession, a paid job. Yes, it's a point. Okay, and scientific informations became more important, especially in universities. Yes. Okay, people start to take lessons for being scientists, for being for achieve this job. Yes, it makes sense. Okay, national differences. Let's compare some countries. France and England. Effects. Sorry, it's mistakes. Effects of Renaissance last more than other countries. Okay, and French universities suffered from French bureaucracy. It's important points. While French universities very well, and other countries students was going there, but then the bureaucracy is affect them negatively. And in England, many scientists had no academic position. But then it will change, of course. In Germany, university students have more freedom, like selecting a topic, and like not like French universities, you know, and has more progress. Yes, in Germany, in 19th century, Germany has more progress. We will see right shortly after. Scotland, chemistry was more common, and scientific research was made slowly, and more practical classes. As I said, chemistry, biology. Okay, United States are relatively little attention to science, and practical attempts is more common from theoretical knowledge, like Scotland. So in industry, it's not very progress when we compare it with Germany. Germany is really progressed in this era. Major industries was founded by inventors like Alexander Graham Bell and like Edison. As you know, there. Even if it's not progressed so much like Germany, it has major scientists. Okay, let's continue with the philosophical basis of 19th century science. Okay, during the 19th century, there were many ideas of philosophers. We will mention about them a little bit. Let's look. Let's see the Hegel. Hegel. I don't know. I pronounced it right. Sorry. He thought that philosophy of nature was based on priori concepts, not observation and experiments based. It's based on priori concepts, priori things, thoughts, sorry. And Auguste Comte, science was the most advanced stage of knowledge, he said. And Ernst Mach, he didn't think a metaphysical stage was needed. It's mean, it's contrast Hegel. Hegel. Sorry. Okay, then how about the science and the public? How was public? How were the public? The 19th century saw general public criticism of some scientific ideas, along with newspaper cartoons and well-attended public meetings attacking specific theories. It means people start to start to support the scientific things, yes, and they start curious, right? Yes. Science and technology in 19th century had a progress between scientific education and technological progress. Scientific education, it means universities are erect and students start to take lessons from scientific technological lessons. Yes. And at the end of the century, universities played a big role in progress industry. They made so many engineers. It developed the country's industry. Like Germany, it's so important in scientific revolution. Okay, and solving technological problems is rather than advancing knowledge was the idea this century. Did you understand me? Contrast to 18th century, it's more based on solving the technological problems, right? Okay. In biology, advancing microscopy, it's help advancing chemistry, chemical products, and in physics, X-rays. Soon after electron, we will see it. Okay. Of course, there were major advances in many fields, like anthropology, archaeology, astronomy, Altamira cave paintings. Pay attention. Here, I will return. Biology, chemistry, communication, computers, construction, of course, earth science, energy, important points. Food and agriculture, materials, mathematics, medicine and health. Physics, importance, it's so important era. Tools and transportation, of course. Okay, pay attention to archaeology, energy, and physics and anthropology. People start to being more developed and not just like Renaissance. It changed a little bit, a little more. Sorry. Okay. So electricity and magnetism. There were often some things found by luck or accidents in electricity and magnetism, but not always. Okay, let's mention about some important people. Benjamin Franklin. He said lightning is electricity, and he made experiments like in this picture. You can research it more in details. Of course, if you curious about it. Charles Augustin Coulomb, connection between electricity and magnetism. He said how can I say? He mentioned about connection between electricity and magnetism. Okay, it's first mentioned about it. Hans Christian Oetzert, electricity. He said electricity and magnetism are really connected. He had proofs, I guess. He had. William Sturgeon. He is the person who first made electromagnets. Okay, in this picture he took it. And Michel Faraday and Joseph Henry, they both studied on dynamo, but Henry was more practical made than Faraday. Faraday is more theoretical scientist. And Edison and Joseph Swan, they made practical lights we use in home. I wish I could show you, but You already know it. Okay, nature of the heat. We will mention about some ideas about heat and some important people. Aristotle, we talk about him so much. I know he is important. Okay, he said that heat here is one of the active elements of a body. Sorry, my pronunciation. What's going on? Francis Bacon said heat is a local motion, and it's with caloric. I mean, caloric is a thing that can pass from one object to another. It's energy. Like Julius Robert Meyer, one of the first to relate heat directly to mechanical work. It's so important because after him, it will change. Study Carnot, heat is indestructible fluid, he said, and mechanical equivalent of heat. He mentioned about it. And finally, James Prescott Joule, he said, heat is destroyed in emission to produce mechanical work. He was think right, and his ideas is living in today these days. Okay, and I think it's final topic, understanding fossils. I as I said, we in archaeology and anthropology is important in these eras, like physics. It's this era is really so developed in many files. Okay, Thomas Jefferson. Sorry, first I should say that in 18th century there was little progress about fossils and archaeology. Not much than 19th century. In 19th century, it will more and more progress. Okay, Thomas Jefferson thought that the creator, the God, wouldn't permit extinction. But here is also Georges Cuvier. Sorry, he said, I have three hypotheses about origins of fossils. One, first, these creatures are still living somewhere on the earth. It's like Thomas' idea. And second, these creatures change shape over time, past. And third, some organisms may be extinct, and we found them as fossils. It's correct one, I think, in my opinion. Okay, friends, it's all. Thanks for your attention, and see you next week in more with more topics, I guess. Bye.